This is packet number 16 in the integration section, and I'm looking at problem number 2. We're given a set of data about temperatures over the course of a day or over the course of 12 hours. And I have gone ahead and made a graph of what the data gives us in that form. I've turned it into a graphical kind of visual for me. And while that's a little time consuming, I often think that it is helpful for people to do such creating the graph. I think is helpful for some people. Okay, so I've gone ahead and done that. Now we're asked to use a trapezoidal approximation to approach to estimate the average temperature between 6 a.m. and 6 p.m. Well, in order to find an average, we need to add up all the area and then divide by the number of hours. So in order to add up all the area, we're asked to take each of these trapezoids and add their area. Well, the area of a trapezoid in general is 1/2 the sum of the bases times the height. So for our first trapezoid, we have to think about our trapezoids. Our bases are the two lines that are parallel. So, which are these two vertical lines. Okay, oftentimes you see a trapezoid being drawn horizontally. Okay, and in here, this line and this line would be your bases. But again, in a trapezoid, the bases are the two that are parallel to one another. So in our case, for trapezoid 1, I need to have 1/2 the sum of the bases, which I have 40 on the left plus 55 on the right times the height. And the height of the trapezoid is the length of the base there, which is, base I should not use, is the delta x in there. So that's a value of 3. Okay. The second trapezoid, well, it's 1/2. Sum of the bases, well, I now have 55 plus, because I'm using that 55 right here, both in the first rectangle and in the second rectangle. So 55 plus 60 times, again, the height, which is 3. Third, is 1/2 the 60. 60 is being used in trapezoid 2 and in trapezoid 3, plus 62 times our base, which is 3. And then the fourth is the 1/2 of the 62. Likewise, it's being used in 3 and in 4, plus 58. Now, obviously, you can take these trapezoids, the first, second, third, and fourth, and just plug that in your calculator to get the total area there. I'm going to simplify this a little bit and have you think about some algebra. I have 1/2 in each of these 4 trapezoids. I also have a 3 in each one. So I could factor out 1/2. I can factor out the 3. And then the other thing I want you to notice is that I have a 55 twice. So I have my 40 plus 2 times the 55. And then I have 60 twice. And I also have 62 twice. And then I have 55 at the end. Take note of your diagram and think about it. As I had highlighted on the earlier part of the screen, was that those middle y values are being used twice. When you are using the trapezoidal rule, that's going to be true, okay? More than likely, your base length is going to be the same, but that's not always true. They could easily have given you data that went from, say, 6 o'clock to 9 o'clock, and then from, instead of 12, it could have gone from 9 to 1. And those width would have been different, so you wouldn't have been able to factor out a consistent number, a constant, and you would have to deal with them individually, which is what I recommend on all of these, is thinking about them individually. There is a formula that can be put together, and you're asked to do that in a later packet for it, but that formula only works if your height of the trapezoids is the same. So I warn you that that won't always be the same, and I ask you to be careful. So if you put these values in, add them up, calculate them, I believe that you get 678. But that is not the average temperature that we have. That's the area of all the trapezoids. In order to find the average temperature, you're just going to need to take 678 and divide it by 12. I think you get 56.5 degrees.